Okay, we're going to go now ahead and construct a confidence interval for estimating a population proportion. So instead of just using the point estimate, like in this example here, 419 people donated blood out of 2296, which is 0.182 or 18.2% of the sample donated blood. Now, what's the estimate for the population proportion of people who donate blood? Well, what we're going to do, instead of using the single value and say 18.2% of people donate blood in the population, we're going to create a confidence interval, use some margin of error to do so. So there's your point estimate. Part B saying verify the requirements. What we know from notes is that for a simple random sample of size n, the sampling distribution of p hat is approximately normal when the mean of that distribution is equal to p, the population, right? And the standard deviation here, this is true provided that n times p times 1 minus p is greater than 10, which we've done before. So it's the same conditions, and that our sampling is from a finite population, meaning that n is less than 5% of the population. So in this case, we're talking about the country, so 2296 is less than 5% of the population. What we really want to get down to is constructing the 90% confidence interval. In order to do that, we have to, again, remember the formula for a confidence interval. The margin of error is what you need to obtain, right? It's the critical value times the standard error, and then you add that to the point estimate and subtract that to get your lower bound and upper bound. So those calculations are done for us already. We have the critical value for z. E is equal to that formula, the critical value times the standard error, and then you get 0.0132. You add that to 0.182 and subtract that from 0.182, and you get two new values here. Those values are your margin of error. You have an upper bound and a lower bound. And so now what we know is we are 90% confident that the proportion of adults who donated blood is between 16.9 and 19.5%. Again, we don't know, even though our point estimate was 18.2, that's just one value. So to be 90% confident of our inference, right, we're doing inferential statistics, we would say that the true population proportion is between 16.9 and 19.5%. Now, there's a way to also do this in StatCrunch. For 9.1, you will be asked to kind of do some of these calculations by hand here. There's a way to kind of check a more precise answer in StatCrunch. Z-stats, one sample with summary. And so what we had was the summary data. What we had was 419 out of 2296. Sorry, wrong one. We're doing proportion stats. One sample with summary, and it was 419 out of 2296. Make sure, yep. And then we're doing a confidence interval. You type that, you click that button there, put a 0, and then compute. And then you have a lower bound and an upper bound. Lower limit, upper, lower bound, upper bound. And so then you have your confidence interval there. So that's, again, using proportion stats on that case with one sample, and we had the summary statistics, and you have your values there. This is what we have right here, and then we're, again, in our interpretation.